Hello and welcome to a new video on IGCSE Physics Classified Paper 2. In this video, we shall be discussing circuits. We shall be introducing V, I, and R, voltage, current, and resistance, which are the three essential variables or components that you measure in any electric circuit. So we shall begin with a basic review of the units. What is the unit of electromotive force? So you should know that there are three quantities that have the same unit, and there is a very slight difference between them. So we have voltage, potential difference, and electromotive force. These all have the same unit because, in a sense, they are measuring the same thing. So these all are measured in volts. So what is the difference between the three quantities? Volts are a measure of the voltage in a circuit, in a sense. Potential difference is basically the decrease in voltage as charges pass through a resistor, for example. So this is a decrease in voltage. Whereas electromotive force is an increase in voltage as the charges pass through the battery, for example. So this is what happens when current or charges pass through a resistor. And this is what happens when they pass through the battery. So potential difference is a decrease in voltage. So it's also measured in volts. Electromotive force is an increase in voltage. So it's also measured in volts as well. So the correct answer here would be choice C. The unit of EMF is volts. The diagram shows a battery connected to two resistors. Four students separately measure the EMF of the battery, the current in the resistors, and the potential difference across resistor R. Remember from last question, EMF and PD are the same quantities. The only difference is in EMF, the voltage increases. In PD, the voltage decreases. They are both measured in volts. So the results are shown in the table below, which row shows values with their correct units. Like we said, EMF is measured in volts. So this is incorrect, and this is incorrect. Current is measured in amperes, not in volts. So this is incorrect, and this is incorrect. And potential difference, like we said, is also measured in volts, similar to EMF. So again, 1.5 amperes would be incorrect. So without any calculations or anything, you just need to figure out which row has correct units for all quantities. And it is obviously row D. So the correct choice here would be choice D. Which quantity is measured in coulombs? So coulombs measure the quantity or the amount of electric charge, which is given by Q. And Q is equal to the current, I, multiplied by the time. We're going to discuss further questions relating to this equation in the same video. However, for now, all you need to know is that coulombs are the unit used to measure charge, which is Q. So the correct answer here is choice A. What is the unit of EMF of a battery? So this is volts, like we said before. So D would be the correct choice. Which quantity is equivalent to 1 volt? So this isn't really a question testing your knowledge of units. It's more of a question testing your knowledge of equations. So the volts are measured, the volts are a way to measure voltage, V. And you should understand that the voltage at any point in a circuit is actually the energy per unit charge. The energy per unit charge. We've discussed previously in mechanics that power is equal to energy over time. So the unit of power here would be joules per seconds, whereas the unit of voltage would be joules per coulombs. As we said in a previous question, the unit to measure charge is coulombs, which is C. So based on this equation, the correct choice would be A. So why is it A and not anything else? So basically, the difference between A and B is this K here, which means kilo. So this is 1,000 joules per coulombs. And this is incorrect, of course, because we just want 1 joule per coulomb. The voltage is 1, so the unit should be also 1, not 1,000. And like we just said, these two are a measure of power, not voltage. Joules per second would measure power, not voltage, because power is energy over time. So the correct choice here would be choice A. 1 volt is equal to 1 joule per 1 coulomb. The energy carried by 1 unit charge, 1 coulomb of charge. So the correct choice here would be choice A. Next, we move on to the definition of electric current, and we mentioned this equation before, Q equals IT. So electric current is basically a measure of the speed of flow of electric charge. The faster the electrons move, the higher the electric current. So an electric current can be thought of as the speed of moving charges. The formal definition is given as follows: I equals Q over T. So this is basically the number of charges passing a certain point, for example, in 1 second. Charge over time, the number of charges passing a point per second. So if I have 1,000 charges passing in 1 second, then my current is 1,000, which of course is very high. If I have 20 charges passing in 1 second, then the current is 20 amperes. And the unit for current is A, which stands for amperes or amps. Let's check out some questions. So a cell is connected to a lamp as shown. A charge of 4 coulombs flows through the lamp in 2 seconds. What is the direction of the electron flow in the lamp, and what is the current in the lamp? So there are 2 types of current, or actually there is one theoretical current and one actual real current. In reality, electrons move from the negative terminal of the battery to the positive terminal. So this is the reality of the situation. What happens in real life is that negative charges move from the negative terminal to the positive terminal. However, if we use this real life model in our analysis, we would have to do everything using negative signs. So what they did was they decided that there is a conventional current, and it's based on what they previously believed to be the case, which is that positive charges move from the positive terminal to the negative terminal. This is not correct. This is not what happens in reality. But this helps us make easier calculations to analyze the circuit. So conventional current, what we used to believe is that positive charges move from the positive terminal to the negative terminal. But if you have watched the previous video on electrostatics, you would realize that positive charges are actually heavy and they do not move. The electrons are the lighter charge that actually is transferred between one point and the other. again, to summarize, conventional current means that we assume that a positive current moves from the positive terminal to the negative terminal. And this is what we use to analyze our circuit. However, in reality, electrons flow from the negative to the positive. So the blue is what happens in reality. The red is what we assume happens to make life easier during calculations. The red is called conventional current. So for the purpose of this question, the direction of electron flow is from left to right. So C and D can be crossed out as incorrect. They go from left to right, from negative to positive. What is the current? So the current can be obtained using the equation Q equals IT. Q is the charge, and we are given that the charge is 4. We do not know the current, and we're given that the time is 2. So the current is equal to 4 divided by 2, and this is equal to 2 amperes. So therefore, the correct choice here would be choice A. The diagram shows a circuit. The reading on the ammeter is 12 amperes. How much charge passes through the ammeter in 2 minutes? So again, Q equals I multiplied by T. I is 12. T is 2 multiplied by 60. So we can use our calculator in order to figure out what the answer is. Or using common sense, you can figure out that the answer must be D because it's the only number large enough to be equal to 12 times 2 times 60. Anyway, let's make sure. I'm going to use my calculator now, and I'm going to multiply 12 times 2 times 60. And the answer is 1,440 coulombs, which is the unit we use to measure electric charge. So the correct choice here would be choice D. In the circuit shown, there is a current of 10 amperes. How much charge passes through the resistor in 2 minutes? Again, Q equals I multiplied by T. So Q equals 10 multiplied by 2 multiplied by 60. And that gives us 1,200 coulombs. So the correct choice here would be choice D. There is a current in a metal wire. Which particles in the wire move to cause this current? Is it protons or electrons? We said that what actually happens is that electrons are transferred because protons are too heavy to move. So the correct choice here would be choice B. Moving on, we will discuss Ohm's law. Ohm's law says that across any resistor, if a certain current flows, then a potential difference is established across the resistor proportional to the current. What does that mean? It means that the higher the current is, the higher the potential difference is. And we will see soon that there are different types of resistors. One type is what we call the ohmic conductor or resistor, and it is characterized by following Ohm's law till the very end. So this is what a graph would look like between I and V for an ohmic conductor. However, for a simple light bulb or filament or whatever, it would still follow Ohm's law initially. So initially, we would have I and V, and we would have a straight line like this. But then after it heats up, because the flow of current makes the lamp hotter, it heats up. So we see that the curve actually bends like this. These are the two types of conductors that we are interested in for the time being. So let's try some questions. Which equation is used to calculate resistance? So like we just said, we know that V is equal to I multiplied by R. So if you want to find R, you would calculate V over I. So potential difference divided by current. We said that potential difference is similar to voltage. It is used to describe a decrease in voltage. And this is what happens when charges flow through a resistor. The voltage drops. So potential difference is a voltage drop. So the correct choice here would be choice D. Four students are each given an identical resistor. So identical resistor means that they all have the same value of R. And they are asked to find its resistance. They each measure the potential difference across the resistor and the current in it. One student makes a mistake. Which row shows the results of the student that makes a mistake? So how do we figure this out? We remind ourselves that R is equal to V over I. So we need to divide the voltage or the potential difference by the current for each one and see what that gives us. So 1.2 divided by 0.5, that will give us 2.4. 2.4 divided 1.1, that gives us 2.18. 1.5 divided by 0.625, that gives us 2.4. And 3 divided by 1.25 gives us 2.4 as well. Why are we dividing? Because R is equal to V divided by I, V over I. So obviously the student who made the mistake is student B, because since they were given identical resistors, they were all supposed to measure two quantities that give us 2.4 when they are divided by each other. They should have all obtained the same answer. So the anomaly here is B, and B is the mistake. An emitter and an 18 ohm resistor are connected in series with a battery. The reading on the emitter is 0.5. What is the EMF of the battery? We said before that EMF is another term used to describe voltage, which we use when we want to describe an increase in voltage. So opposite to potential difference, EMF means that the voltage increased, and this happens inside the battery. So how do we get EMF? Again, this is V, so V equals IR. You need to understand that voltage and EMF and PD, potential difference, are all represented with V. So this equation applies to all of them, whether it's voltage or EMF or potential difference. So anyway, here the current is 0.5 amperes multiplied by the resistance, which is 18 ohms. So the correct answer would be 9. Is it 9 newtons or 9 volts? Of course, it's 9 volts. So the correct choice here is choice B. Now we move on to the graphs that follow Ohm's law, V equals IR. We are given 4 graphs and we want to know which of these applies to the ohmic resistor and which of these applies to the filament lamp. Like we said, the ohmic resistor exhibits a constant relation between current and voltage, whereas a filament lamp exhibits this relationship, which is sort of similar to the graph of terminal velocity from mechanics, if you remember. So this would be the ohmic conductor, and this would be the filament lamp. And the correct answers here would be X and Y. So B is your correct choice. A small potential difference V is applied across a filament lamp. Remember, filament lamp is similar to the graph of terminal velocity. So the current is measured, V is increased, and I is measured at each stage, which graph shows the results obtained. So we already know that it's not C and D, but is it A or is it B? We said that initially it looks like Ohm's law. It looks like an ohmic conductor, I mean. So initially it's sort of constant, and then it starts sloping downwards. So this is the correct choice. The problem with B is that For 0 voltage, it has a current, and this never happens. When the I is equal to 0, the V must equal 0 as well, because V equals IR. So when one is 0, the other must be 0 as well. So the correct choice here would be choice A. Which diagram is the current voltage characteristic graph for a metallic conductor at constant temperature? Remember that what distinguishes the metallic conductor and the filament lamp is that the filament lamp heats up. This is why the graph slopes. Excuse me, this is why the graph curves. So at constant temperature, and anyway, when they say metallic conductor or ohmic conductor, this is the conventional V equals IR graph, which is a straight line. We would have chosen A had they asked for the graph of a filament lamp. So you have to distinguish between metallic conductor, which is what we circled, and filament lamp, which is the graph in choice A. So the correct choice here would be choice D. The graph shows the relationship between the current in a circuit component and the potential difference across it. The graph has a straight section and the curved section. What happens to the resistance of the component in these two sections as the current increases? So first of all, this could be viewed as a mathematical problem anyway, but because the resistance is equal to voltage over current, right? So if we divide voltage by current in this part is linear. So it has a constant slope from mathematics, right? And since it has a constant slope, we can rest assured that there is no change in the resistance. So for the straight section, we know that A and B are wrong. And we want to figure out what happens in the curved section. You can think of it in terms of the following. What happens here? As I continues to increase, so if we were to draw an extension of the red line like this, what happens here? It would follow the path of the green line. But what actually happens is that it curves downwards. So what happens when it curves downwards? The y is decreasing in a sense. So here, the y is less than what it should have been. So the y in this graph is the current. So if the current decreases, what happens to the resistance? The resistance is inversely proportional to the current because the I is in the denominator. So if I decreases, R increases. That's one way of looking at it. You could have also approached this mathematically. You know that the slope is equal to change in y, y2 minus y1, over change in x, x2 minus x1. So in this case, our slope is the change in current over the change in voltage because the current is in the y-axis. Now, from math, you might be able to figure out that in this graph, the slope is decreasing. So if the slope is decreasing, then I over V is decreasing. But we want R, which is basically V over I. So it's the inverse of that. It's the multiplicative inverse of that. So if the slope is decreasing, then R must be increasing as well. These are two different approaches to figure out that the resistance increases. And we said, of course, that in the straight line section, there is no change in resistance. So the correct choice here would be choice D. This is not an easy question, to be honest. I hope you understood. So the graph shows the way in which one physical quantity y varies with another physical quantity x. Which row gives suitable quantities for y and x? So this question sort of combines various units of physics. So in choice A, the number of atoms of a radioactive isotope, this has to do with nuclear physics, which we might not have studied yet. But anyway, it's wrong. B, potential difference across a metallic conductor and the current in the metallic conductor. We already know that in a metallic conductor, Ohm's law is followed, and this is what the graph looks like. So B is the correct choice. C and D are not really relevant to this particular video, but they are incorrect. So here we're just testing that you know that the graph of V equals IR across a metallic conductor looks like a straight line, and B would be the correct choice. Moving on, we will discuss now voltmeters and ammeters. Obviously, these are meters used to measure certain electrical quantities. Voltmeters measure volts, voltage, and ammeters measure current in amps. You should know that in an electric circuit, an ammeter is connected in series, whereas a voltmeter would be connected in parallel, depending on what I'm trying to measure. So if I'm trying to measure the EMF in the battery, I will connect the voltmeter as such. If I'm trying to connect the potential difference across a resistor, I would connect the voltmeter as such. And the current is the same in all the circuits, so the ammeter will measure the current. I can connect the ammeter anywhere as long as it's in series. In series means it's like inside the circuit. In parallel means I have to create a branch outside of the circuit to connect the voltmeter. So in this question, they say the circuit shown includes 2 meters X and Y connected correctly. Which row gives the unit of the quantity measured by X and the quantity measured by Y? So we can see that these are both connected in parallel, and therefore they are both voltmeters. So the correct choice here would be choice D, volt and volt. 2 meters are connected in a circuit to measure the current in a component and the potential difference across the component. Which meters are used and how are they connected? Excuse me, I'm sorry. So we know that an ammeter is connected in series, not in parallel, so this is wrong. And voltmeter is in parallel, not in series, so this is wrong. And the ammeter measures current, so this is correct. Voltmeter measures potential difference, so this is correct. Here they are flipped. They say a voltmeter measures current, which is wrong, of course. So the correct choice here would be choice B. Which circuit shows a voltmeter measuring the PD across a resistor? So first of all, the voltmeter must be connected in parallel, not in series, so this is wrong. Here, the voltmeter measures the PD across the lamp, not the resistor. In D, the voltmeter measures the EMF of the battery, because we said EMF is associated with the battery and the increase in voltage. The correct choice would be choice B, where the voltmeter measures the PD across the resistor. This is the resistor, by the way. So therefore, the correct choice would be choice B. A student connects a circuit with a power supply, a lamp, and an ammeter. Where must the ammeter be connected? So, of course, we said that the ammeter is connected in series, not in parallel, so A and B are wrong. Now, is it used to measure current or potential difference? Of course, potential difference is wrong. An ammeter is used to measure current and connected in series. So C is the correct answer. Which circuit can be used to determine the resistance of resistor R? We said that the ammeter is connected in series and the voltmeter is connected in parallel. So A and B are wrong because the voltmeter is connected in series. And D is wrong because the ammeter is connected in parallel. C is the correct choice because the ammeter is in series and the voltmeter is in parallel. So C would be the correct choice here. The circuit shown contains a battery, a 6-ohm resistor, and 2 meters X and Y. 1 meter records current and 1 meter records potential difference. Which row shows possible values for the readings? So first of all, meter X must be an ammeter, meter Y must be a voltmeter because the first is connected in series and the second is connected in parallel. So X has to measure amps. So B and D are wrong. And Y obviously has to measure in volts. So now A and C are correct in terms of units, but which set makes more sense? Of course, it's set A, because V equals IR. And if I apply the values in A to this equation, I would get 12 for V, 2 for I, and 6 for R. So this would be the correct choice. However, in C, if I apply the values, they would not yield the correct equation. Therefore, choice A is the correct answer. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.